Let us solve another problem. Namdyal is at a distance of 560 kilometers from Bangalore. Okay, so there is a station Namdyal, okay, and the another station is Bangalore. Okay, a train starts from Namdyal towards Bangalore, and a train 2 starts from Bangalore towards Namdyal. Okay, and they have given the distance between these two stations, that is 560 kilometers. Okay, so the distance between the two stations that are given, okay, that are Namdyal and Bangalore, are 560 kilometers. Okay, they have straight away given the distances, and one train starts at Namdyal towards Bangalore and other train starts at Bangalore towards Namdyal. Okay, and a train starts from Namdyal to Bangalore at 6 a.m. Okay, so it starts at 6 a.m. with a speed of 40 kilometers per hour. 40 kmph, and from Bangalore a train starts at 7 a.m. with a speed of 60 kmph. Okay, so previously whatever the problem that we have solved, both start at same time, but here one starts at 6 a.m. and the other starts at 7 a.m. It means that both are not starting at same time. Okay, so one start at 6 a.m. after 1 hour the next train, the other train from the other end is getting started. Okay, so now how to solve these kind of problems? Okay, so the distance between these two is 560 kilometers as per the question, right? Okay, in order to write this in a form of an expression, okay, at least one parameter must be equal. Okay, so here we have total 3 parameters, right? Velocity, distance, time. Okay, so here velocities are not equal. Distances are also not equal, obviously, because as they are having two different velocities, the distance traveled by each train may not be the same. Okay, so the distances are not equal, the speeds are not equal, even the times are not equal, right? Because they are not starting at the same point of time. Okay, one starts at 6, one starts at 7. Okay, see, you have to consider, or you have to write an expression, okay, by considering the trains starting at the same time. By considering the, even though one train is starting at 6 a.m., you have to consider first train and the next train, both the trains are starting at the same point of time. Okay, it doesn't mean that you have to take this as 7 a.m. Okay, so at 7 a.m. what will be the position of this train? Okay, so as per the velocity that has been given, okay, so from 6 a.m. to 7 a.m. the duration is 1 hour, right? What will be the distance traveled by this train in that 1 hour? 40 kilometers per hour, right? Per 1 hour it will travel 40 kilometers. It means that from here to here it might have traveled 40 kilometers in that 1 hour from 6 a.m. to 7 a.m. Okay, so now the time is 7 a.m. 7 a.m. here, and even here it is 7 a.m. Okay, so by the time the train 1 will be here, the train 2 will be here. What is the distance between these 2 points? By excluding the 40 kilometers, 560 minus 40, that will be 520 kilometers. Okay, so you have to consider such that so you have to consider this such that both the trains from a same time period or a same point of time. Okay, so at 6 a.m. this train hasn't started. Okay, and at 6:30 then also this train has not yet started. At 7 only it starts. Okay, so by the 7 a.m. what will be the position of this train? Where will it be? From that point what will be the distance? Okay, so from this point the distance is 520. Okay, so like that you have to consider this like that to equate the times to get an expression in order to write this in an expression. Okay, so now as these are starting from the same time period, same point of time, okay, you can now equate the times. Okay, so t1 equals to t2 and you have to write the times in terms of distance and velocity. And what is the distance traveled by the train 1? Okay, let us take that as x, and what is the velocity of that? That is 40, and that equals to, okay, the total distance is 520. If the distance traveled by the train 1 is x, the distance traveled by the train 2 will be 520 minus x by the respective time of the velocity of that is 60 kmph. Okay, so if you solve this, you can easily get the answer. Okay, so now it will be 60x, that is equals to 40 into 520 minus 40x. Okay, so if you take x terms on one side, 100x is equals to 40 into 520, and if you cancel this, x is equals to 208 kilometers. So x is 208 kilometers from here. Okay, so because we have considered the x as this x corresponds to train 1, right? So from this point, okay, within a time, okay, after a particular time, whenever they meet, okay, so from this point till the meeting point, the distance is x. Okay, this is not the station from which it has been started. Okay, it is a point somewhere means at 40 kilometers from the station that it has started. What is the distance from Namdyal? Okay, this total distance from Namdyal, here it is 40 and here it is x is 208. Okay, so 40 plus 208, that will be 248. Okay, so they will meet at some point, okay, somewhere here. So okay, the distance from here to here, the station where it has started, that is Namdyal. From Namdyal, it is at a distance of 248 kilometers. Okay, so 248 kilometers from Namdyal. Okay, so how we got that? So 40 plus 208, okay, that will be 248 kilometers. Okay, so that will be the distance from Namdyal station. Okay, and what is the time to meet? Okay, at what time will the two trains will be at the point of crossing? We have to find the time also. Okay, so what will be the time? We know the distance, right? Distance is 248. Okay, and what is the velocity of this train? That will be 40 kilometers, right? 40. Okay, so this will be, see, this is the distance and this is the velocity. Okay, t is equals to d by v, right? So if you do this, you will get the answer. Okay, you will get the time to reach the crossing point. Okay, so if you just cancel this, so it is 6.2 hours. 6.2 hours. Okay, 6 hours. 0.2 hours. 0.2 into 60. That will be 12 minutes. Okay, 6 hours 12 minutes. Okay, from what? 6 hours 12 minutes from what station? Namdyal station. When the train has started from there? At 6 a.m. Okay, 6 a.m. plus 6 hours 12 minutes. Okay, so then they will meet at 12:12 p.m. Okay, so they will meet at afternoon 12:12 p.m. Okay, this will be the answer for this. Okay, and you can even solve this in other way. Okay, so from here it is 248, right? What is the distance from this station? If you calculate that distance divided by the velocity, that is 60, then also you will get the same time. Okay, or then you will get the time as 5 hours 12 minutes. Okay, 5 hours 12 minutes plus 7 a.m. Okay, if you add them, then also you will get the same answer. Okay, this is how you have to solve this. Now let us solve another problem. So far what are the problems that we have discussed? Okay, there two trains will be there which start from two different stations, but here it is different. Both the trains are starting from a single station at different times. Okay, so a station is there. Okay, let us consider the station as some x. Okay, so from here the train 1, okay, so this will be the train 1 which starts at 5 a.m. okay, with a speed of 60 km/h. Okay, and now another train starts from the same station, that is train 2, at 6:30 a.m. 6:30 a.m. with a speed of 75 km/h. Okay, at after what distance from the station X will they meet, and at after what time? Okay, this is the question. So here velocities are different. Okay, and even if you observe this problem, this is similar to the problems that we have solved in the topic of chasing. Okay, so there will be one policeman having a different velocity and a thief of different speed. Okay, so the thief, whenever he identifies the policeman, whenever he saw the policeman, he immediately runs. Okay, after what time the policeman catches the thief? Okay, so before he is caught, what will be the distance traveled by the thief or the policeman, or like that the questions will be asked. Okay, even here also it is similar to that. Okay, so one is having one velocity and one is having the other velocity, both are traveling in same direction. How to write this in a form of an expression? Okay, so but for that, in order to write this as an expression, you have to consider same point of time. Okay, so it is starting at 5 a.m. it is starting at 6:30 a.m. right? So you have to write the both at a single point of time. Okay, so take both at 6:30. Okay, so both at 6:30 if you take, so from 5 to 6:30, 1.5 hours is there. So per 1 hour it travels 60 km, right? So in 1.5 hours, what will be the distance traveled by the train? Okay, so let this be point X. Okay, whenever the time is 6:30 a.m. by that time, the train 1 is at a distance of 60 plus half of 60, right? 1.5 hours, that will be 90 kilometers from station X. Okay, the T1, the train 1 will be here and the train 2 will be here. Okay, and the velocities are, this is having 60 km per hour velocity and this is having 75 km per hour velocity. Okay, now by the time of 6:30 a.m. these are the positions of train 1 and train 2. If now the timing, the countdown starts, after what time from 6:30 will they meet? Okay, at what distance from X will they meet? Okay, like that if the question is asked. Okay, we have already used a formula in the case of the chasing, that is in order to find the distance, that will be equals to delta D into A by A minus B. Okay, where A and B corresponds to the velocities. Okay, and delta D is the distance, the initial distance between the two objects. Okay, there it was the distance between the thief and the policeman. Here it is the initial distance between the two trains. Okay, that is 90 kilometers here. Okay, and what is that they are asking? At what time and what distance from the station will they meet? From the station in the sense whether you have to consider T2 as A or T1. Okay, what is at the station when the time is 6:30? T2, train 2 is at the station, right? So A corresponds to the velocity of T2. T2 velocity is how much? T2 velocity is 75 km per hour and the difference of velocities is 15. Okay, so 75, 60, right? 15. Okay, and this will be 450 kilometers. 450 kilometers is what? D. What is D actually? The distance traveled by the train having this velocity. what is this? 75, right? 75 corresponds to what? The train T2, okay, the second train, okay, and you know, whatever is this 450 kilometers, suppose if this is the meeting point, this distance from X, okay, from the starting point of T2 at the time of 6:30 am, this distance is 450 kilometers, okay. So we have got one answer, that is the distance of the meeting, okay, the meeting point distance from the station, that is 450 kilometers, okay. Now what we need to find? The time after which will they meet, okay, or the point of time at which the two trains meet, okay. So 450 kilometers is the distance traveled by T2, train 2, and the respective velocity is 75 kilometers, right? And the respective velocity is 75 kilometers per hour, right? So now, you know, time, the point of time, in order to find that, 450 by 75, okay? So this will be 6, okay? This will be 6 hours. So you have to add the 6 hours to what? 6:30. Okay, so now after adding you will get this as 6:30 plus 6 hours, that will be 12:30 p.m. Okay, so the two trains, wherever they meet, the meeting point distance from the station is 450 kilometers and they will meet at a time of 12:30 p.m. Okay, so this is how you have to solve this. Okay, so here we have considered the time, velocity, you know, distance of train 2. Okay, similarly you can consider the distance traveled by the T1 and its velocity to find the time, and you can add it to that, okay, whatever is the 5 am. Okay, so that way also you can solve this. Okay, this is, you know, either way you can solve this, either by considering the train 2 or train 1. Okay.